In this module, we will enhance our existing CRM app using a pair of handy technologies, structured data, and local version control. We have lots to cover in this module. Our CRM database from the previous module used statically defined Python data inside the source code. We'll explore 3 different syntaxes of structured data so we can decouple our data from our code, focusing on JSON, YAML, and XML. Now that we have many different files in our project, both code and data, I'll introduce using the Git version control system to track changes. This includes several demonstrations where I'll teach you the basic Git operations most commonly used. I'll finish up by explaining how to compare files using the diff mechanism, which is also built into Git. Do you remember our bash demo earlier in the course? Can you see any problems with the output we received from it? Many shell programs, whether it's bash or a network device command line, will give you plain text in response to your commands. This is great for humans to read, but difficult for machines. Complex parsing techniques are normally needed to extract and process individual pieces of data. If we use some kind of structured data, we could easily load that into memory without parsing. Think about the syntax required to build a Python dictionary. If we type that into a file, how hard would it be to transform it into Python data behind the scenes? Probably not that hard, and this is the power of structuring our data. I hinted at this last point on the agenda slide, but pulling that static Python data out of our code and into a separate data file improves the maintainability of our project overall. In a large project, you might use a real database, but using simple files will illustrate the point just fine for our use case. Let's jump into a few examples. Suppose we want to maintain a list of our customers along with their attributes for loading into our CRM app. This example is JavaScript Object Notation, or JSON. JSON dictionaries are wrapped in curly braces, much like Python dictionaries. In fact, JSON formatting is almost identical to Python formatting, both in syntax and semantics. Like Python, lists are annotated using square brackets, and in this case, we have a list of dictionaries. Each dictionary in this list has 3 keys. They represent a mix of string, integer, and Boolean attributes describing each customer. Between elements in a list, a comma is used just like Python. Then we have another customer with the same dictionary key names but different values. This structure would be very easy to load into Python, don't you think? Next, let's check out YAML, which is YAML Ain't Markup Language, a goofy recursive acronym. YAML is a superset of JSON, meaning it can do everything JSON can do along with some new features. One basic feature is comments using the hash symbol, similar to Python. YAML files conventionally begin with triple dashes. The scoping in YAML is done using whitespace, also like Python. You can technically use square brackets for single-line lists or curly braces for single-line dictionaries, but that's rare. Here, we have a list of dictionaries again. The dash in YAML is a point of confusion for many. It indicates the beginning of a list element, so in this case, we have a list of 2 dictionaries with 3 keys each. Although I recommend always quoting your strings, YAML doesn't require it unless the literal colon is contained in the string or you want to do fancy escaping. Just be aware of this caveat. You can optionally end your YAML files with 3 periods, and this is often a good idea. YAML doesn't have any closing delimiters, so accidentally truncating data is a real problem with YAML. Last, we finish up with XML, or Extensible Markup Language. This is the most tedious to read and write, but also the most powerful. XML documents must begin with an XML header indicating the version and encoding style. They also must be encapsulated in a single element, which means we cannot have a list as our topmost element. I've named mine root, but you can use any name. Inside this root element, I have more nested items. Each item is a customer list element which contains 3 sub-elements. You can probably see the resemblance to JSON and YAML. Note that elements must be explicitly closed using the element name preceded by a /. XML has a secret weapon. It can embed metadata in each element, which are called attributes. I've modified the XML slightly to illustrate this with green text. In YAML or JSON, we would normally specify these attributes as keys, but XML gives you more options. In my experience, this is harder to read and makes it harder to convert into YAML or JSON. I suggest avoiding it, but you should be aware of the capability as it will become relevant in a future course on network programmability.